Thank you very much. Welcome again to our usual YouTube tutorials. Today I want us to look at how to use a factor formula to integrate trigonometric functions. I have an example here. 1. We are to integrate the cosine of 2x cosine of x dx. Secondly, I have a sine of 4x, sine of 3x. This time I brought examples which are similar. This as a cosine, a cos, this as a sine. In the next episode, we will see how we can see integrals having a cosine and a sine combined. So, we should be having a quick reminder. When you have an integration, that is having a multiplication of similar trigonometric ratios, let's say a sine or a cos, your head must quickly run to remember the factor formula. And you have to know that if the trigonometric ratios are similar, then that should be obviously either addition or a subtraction of a cosine. So, let's have a quick reminder. A cosine of A plus a cosine of B will give us this, according to our factor formula, and a cosine of A minus a cosine of B will give us that. Now, if you look at the first one, cosine of 2x, cosine of x, it is similar to this. So it comes from a cosine of A plus a cosine of B. Let us look at how we can solve the first one. We have integral of cosine of 2x, cosine of x dx. So, this one is similar to the first factor formula that we have, cosine of A plus cosine of B. So, we say from cosine of A plus cosine of B, this will give us a 2 of a cos of A plus B out of 2, then cosine of A minus B out of 2. That's what we have. So I want to divide both sides by 2 such that I can have this side similar to this so that we can compare them. And then we solve for the values of A and B. So therefore, when I divide both sides by 2, I will have this is a half cosine of A plus cosine of B is equal to cosine of A plus B out of 2, then cosine of A minus B out of 2. That's what we have. So when we have reached here, I am going to compare this side with this one because it's the one that has multiplication, the value has a multiplication, so that we can find the values of A and B in terms of x. So we are comparing cos A plus B out of 2, and then cos of A minus B out of 2. We are comparing with this, so this is cos of 2x, cosine of x. We are comparing the 2. So on comparison, you see that A plus B out of 2 is 2x, is equal to 2x. So therefore we know that A plus B out of 2 is equal to 2x. And this implies that A plus B is going to be 4x. Multiplying both sides by 2 will give us this. I can call this equation 1. Similarly, also, I have that A minus B out of 2 is just equal to x. So on multiplying both sides by 2, we will have that A minus B is equal to 2x. We can call this equation number 2. Then the next step is we are going to solve 1 and 2 simultaneously. I'll first add it, then we subtract. So equation 1 plus equation 2. So we'll have A plus B equal to 4x. And then I have A minus B equal to 2x. On addition of the two, we will have A plus A will give me 2x. B plus negative B will be 0, and this will be 6x. So this is 2A, not x again. So on dividing by 2, so I'll have A alone. This implies that A is actually 3x. Our A is 3x. Let's also say similarly, also, we will have that equation 1 minus equation 2. Equation 1 minus equation 2. I will have A plus B equal to 4x. Then I have A minus B equal to 2x. On subtraction, I will have this cos A minus A equal to 0, B minus negative B will be 2B. And this will give me 2x. So divided by 2, this implies that our B becomes simply x. So we have solved for A and for B. So the value of A is 3x, the value of B is actually x. So I'll come back to this step. So that implies that I have, okay, let me first say from half, open a bracket, cos of A plus cosine of B is equal to cosine of A plus B out of 2, then cosine of A minus B out of 2. So I am going to replace for A and B wherever they are. It is obvious that this now implies that I will have a half, open a bracket, cosine A is 3x plus B is x cosine of x will be equal to A plus B will be 3x plus x will be 4x. When I divide by 2, I'll get 2x. So this will be cosine of 2x. Cosine again. 3x minus x will be 2x. Divided by 2 will be giving me x. So this is what we have. So you see that this is actually similar to that. So it means when I have this is the same as that. So therefore, when I am to integrate cosine of 2x times the cosine of x dx, this one, a cosine of 2x, cosine of x, is the same as a half of cos 3x plus cosine of x. So this will be still the integral of a half, open a bracket, cosine of 3x plus cosine of x, and this is x. So this is a constant. I can bring it out. This will be equal to a half integral of cosine of 3x plus cosine of x dx. So finally, this is a half. This one, when I integrate a cosine of 3x, when you differentiate this, you get 3. You get the reciprocal of that, that will be a sine. And then this is the sine. You maintain the angle 3x plus. When I integrate a cos, this will be sine of x plus, of course, c, arbitrary constant of integration. We don't have the limits. So this one becomes a half. This one becomes, actually, when I multiply, I have this 1 out of 6 sine of 3x, and this one becomes plus a half sine of this implies that integral of cos to x cosine of x dx will give us 1 out of 6 sine of 3x plus a half sine 2x plus c. This is how the factor formula makes these integrals to simple. Thank you very much.